Context7, you push a feature an AI coding agent wrote. It compiles. It passes your tests. Then in production, it calls a method the library removed 3 months ago. The subject is Context7, an MCP server and API that injects current version-specific library documentation directly into coding agents like Cursor, Claude Code, and Copilot. The central question is simple. Does giving agents live documentation actually stop them from using outdated or wrong APIs, or does it just swap one failure mode for another? Coding agents are built on large language models, and those models are frozen at a training cutoff. Libraries like Next.js, React, or Pydantic release breaking changes faster than that cutoff can know about. The symptoms show up everywhere. Functions that never existed, parameters that were renamed, middleware patterns that were deprecated, and imports that moved to a different package. The real cost is not the bad line itself. It is the launch day rewrite, the red CI pipeline, the hour-lost debugging code that looks correct but is silently tied to last year's API. You could ask the agent to search the web, but search returns pages and the agent still has to choose the right page, read it, infer the version, and avoid the outdated result at the top. Context7 changes the pipeline. Instead of asking the model to remember, the agent formulates a query, retrieves ranked documentation snippets at request time, and generates code from those snippets. And you can pin the exact version. The library ID format is /owner/project/version, so the agent sees the API that matches the dependency in your package file. Context7 can index public Git repositories, websites, OpenAPI specs, LLMS, TXT files, Confluence spaces, Notion pages, and private sources on higher-tier plans. It parses documentation files like Markdown, MDX, ray-structured text, and Jupyter notebooks, then extracts code examples. If the docs are thin, it can fall back to source code-derived examples. Library owners can commit a Context7 JSON file to control what is included or excluded, and deprecated folders are filtered out by default. The agent uses 2 MCP tools. First, resolve library id to find the exact Context7 library. Then query docs to fetch snippets for a scoped, single-topic question. The query is re-ranked server-side using well-known large language model providers. Context7 returns only the most relevant snippets, not the whole documentation site. A live API call for React Dev returns over 6,000 snippets, around 677,000 tokens, and a last update timestamp from today. Refresh is not real-time, but it is popularity weighted. Top 100 libraries refresh daily, top 1,000 every 15 days, top 5,000 every 30 days, and everyone else every 45 days. Privacy is designed around minimization. Your original prompt and source code stay inside the assistant. Only the formulated query and library identifier are sent to Context7. Before snippets reach the agent, indexed documentation passes a classifier that flags prompt injection attempts and malware-related patterns. That refresh policy is the first limit. Even popular libraries can lag a day. Websites refresh slower than Git repositories, and niche libraries may wait longer. Coverage is uneven. A popular library gives you thousands of snippets and a high trust score. A niche or newly added library may have few snippets, a lower score, or no version entry at all. The query quality gate still matters. A vague query like auth returns generic snippets. A specific query like how to set up JWT authentication with Next.js middleware returns actionable code. Every retrieval costs tokens and rate limit budget. Free plans are capped. On Enterprise, extra calls and private source parsing are billed per seat and per million tokens. Even a current snippet is not a guarantee. The documentation itself can be wrong, and the agent can still misread a correct example. Private sources add a discipline requirement. They are not refreshed automatically on lower tiers, so internal docs are only as fresh as your manual refresh or webhook setup. Context7 wins where the gap between model memory and reality is widest. Fast-moving libraries with rich, version-specific documentation that your code depends on directly. It stalls where docs are sparse, tasks are vague, the API is internal, or the error is conceptual. Retrieval helps with facts, it does not fix reasoning. So before installing it past 3 gates, does your stack change faster than your model's cutoff? Do you call version-specific APIs? And are you willing to pay the token and rate limit cost? The verdict: yes, Context7 can materially reduce outdated and incorrect API usage, but only when coverage, prompt quality, and refresh speed line up. To try it, install the Context7 MCP server, add a rule so the agent invokes it for library questions, and pin the exact library version in your prompt. Live documentation narrows the gap between what a model remembers and what the API looks like today. The remaining risk is how well you ask and how closely you monitor how fresh the answer really is.